So welcome to the San Diego C++ Meetup, broadcasted directly from America's finest city, as we just mentioned. Okay, so again, welcome everyone. I'm trying to get my setup in a way that I can see some of you. So what I'm going to do, give me a sec, 1 second. There is a nice way to have a slideshow. Custom. No, but where is it? Oh yeah, this one. Okay, so I can do this. Awesome. Okay, so hopefully you can see my what I'm sharing right now. And the funny part is, where do I see? I can see my my notes. Okay. So much for that. So I'm just gonna do this and full screen. Yeah, okay. Prefer having. Okay, so again, welcome to our 35th San Diego Meetup. As I mentioned before, I am trying to come up with topics that are kind of suitable for all kinds of levels, not only beginners, not only expert. Actually, not looking at expert. I'm trying to kind of have something in between expert and beginners. I'll show some beginners, and sometimes I'll show a bit of more of an expert level. But the idea is that we can share C++ ideas and share knowledge, and I'll usually come up with topics that I think are interesting for all of us to discuss. Feel free to stop me if you have any question, and either myself or others on the call can chime in. I am definitely looking for people that would like to contribute in the next sessions. So feel free to approach me if you have anything that you would like to present, and it can be anything from oh, I've seen something while walking at work, or some toy project and I want to share with either a bug or some aha moment. And there's lots of stuff that I learn every day from looking at my code, others' code, the web. There's a lot of things that we can share. So yeah, feel free to come to approach me. You don't need to be expert. You're actually being an expert by taking something and presenting 15, 20, 30 minutes. Doesn't really matter. Actually, I think shorter sessions are easier to digest and can be more focused. So that's this my opinion. So usually I'll come up with an agenda. Here's today's agenda. We'll have the traditional C++ quiz from C++ quiz website. Then I'll show something that I picked up from Reddit subchannel C programming about multithreading help. And this is an example. I took something from Reddit and I said, okay, this can be fun to take and first fix it for the person asking. Simple race condition that you'll see. And how would it look like modernizing it with C++ 11 and above? Obviously, I'm showing few options. There are other options to modernize it. It's just an example. Book of the month. I'll talk about book of the month when we get to it, it's a bit different from what I usually present. Then Stack Overflow, I'm taking something that talks about Studless and explaining more about what is the magic behind Studless. And when do you want to use Studless and when do you want to specialize it, when you don't want to specialize it. All these small subtleties would be hopefully answered in this section. Then few slides from the famous WalletFox website, kind of a recap from the previous session, Ben Dean's comment. I thought maybe I should just take his comment and just write it up so people can actually refer to it. He had at least a couple good comments that I just put on paper, like digital paper, that is. And then something that I actually never done before, which is I took, long story short, I took a Leetcode and decided to do a TDD on it, and kind of influenced from a book that I'm reading. And when I say I'm reading a book, actually reading like few books in parallel, kind of round robin between them, which is not a good idea, by the way, but that's what I just end up doing. So there is a book from Uncle Bob, if you know Robert Martin, and like a new book, and I think it's from Inform IT publication, like Pearson, I think, and there is something there that kind of was very interesting that I wanted to share. So so we'll talk about it. I'm part of Qualcomm wireless department, and I just want to thank Qualcomm for sponsoring that meetup. They're paying the meetup fees. Specifically, my VP Charles is a great supporter of this meetup. So thank you all, Qualcomm and Charles. And we have at Warbox where I just upload my slides. The Slack channel that I have here, I'm not actually using the Slack channel and Discord again. I am sometimes on Discord. It's sometimes open and I have it on my phone. So if someone wants to contact me through Discord, I would actually reach. They can reach out to me because I have it on my phone. So YouTube channel, we have YouTube channels, SDCPP MU, so the San Diego C Meetup. And we have sessions uploaded, I think almost 2 years worth of sessions on the Meetup channel. I am maintaining the Twitter account of SDCPPMU, and I have my own Twitter handle, which is Kobe_CA. Sometimes when I have time, I would write something on Warbox blog, but I not writing as frequent as I would like to. So there are few there that Martin is hosting for me. Okay. Any question? Let's see. Okay, so let's dive into. So what I'm going to do is I'm going to open a tab. And just going to share it. So we have you quiz. So I have 4 of them. One of them I have a CPP Insight link, which would be interesting. Okay. So we have 281, 39, 41, and 76. Okay. Let's start with let's start with 281. So I'll share this. Okay, CPP quiz. Okay, so I'll give you a sec to read that.
Hey, Kobe, could you zoom in? I think it's a little bit hard for most of us to read that.
Okay. Pretty big monitor, so I don't have a sense of. Okay, is this fine or more?
Just a bit more, maybe. There we go. That's
perfect. Okay. Okay, so CPP 17. By the way, most of them are CPP 17. Difficulty would be 1 out of 3. So we have a class with 2 functions. One is a constructor, one is a copy. User declare disable. So this is important. Just as a FYI, if we declare, and there is this matrix, forgot the name. He's the guy that actually wrote the Chrono library. Forgot the name, but there is a very nice matrix that says like what happens if user declares something. So what is being disabled by the compiler and all. So this is one, just kind of an FYI. This is disable move constructor. That's something that the question it's embedded in the question. This is basically kind of a not the best practice. If you don't need to create any of them, don't create them. But just for the sake of this question, it's being created. So we have this C instance, and then C, C2, and then StudMove of C. And then we are trying to print OK. So there are a few options. Either there is an output, compilation error, unspecified implementation defined, or undefined behavior. And you can shout, by the way. This is the place where you shout the answer. Okay, so there is an instance of C here. Nothing happens, right? There is just nothing is printed. This is valid, right? There is nothing special. Okay, so we have StudMove of C. What StudMove of C is? StudMove doesn't move anything. Just like you can think about it as a cast to RValue reference. Yeah. So C is an RValue reference, and we basically invoke a specific function. So this is saying disabling move constructor. So one would think that since it's disabling move constructor and this would bind to a move constructor, maybe this would not compile, but that's not actually true. It's actually compiles, and the simple answer is going to be okay. And what happened here is, if it's the first time that you're actually looking at CPP Quiz, there is a very comprehensive explanation of what's actually happening. And long story short, although this is kind of casted to an RValue reference, it still can be bind to a constref. And constref is it's pretty nice. It binds to a lot of things. It binds to temporaries, and it binds to L values, and so on and so forth.
My oven thing without him.
Yeah. Okay.
So I'm going to mute few people on the bridge because otherwise. Okay, it's muted. Okay, thanks. So long story short, even though you think that this is a supposed to bind to a move constructor, it's disabled, and we still have something that the compiler can pick the right function, which is a ConstRef, and this can be bind to ConstRef. And even if I had here a temporary of C, it still binds to a ConstRef. So this thing is valid. Okay, let's go to the next one.
Kobe,
yeah,
could I ask you a question? So does it have to be a const cref? I mean, would that still work without the const reference?
So the problem with non-constref, it cannot bind to a temporary. So
Okay. Okay.
So
That's what I thought. Okay.
the compiler should so the compiler is pretty helpful here. I cannot bind a non-const RValue reference to a non-const reference, and this is what happens here. So
Okay.
even
So
if
the const is the key.
Yeah, the const is the key. The const. There is a very good article from the past few days from, was it Vittorio? I can't remember if it was Vittorio or someone else. Someone actually wrote something about, oh, no, it wasn't Vittorio. It was, keep forgetting his name. It's embarrassing.
Is it Arthur Dwyer?
Arthur Dwyer, yeah. He had a column about binding universal reference versus forwarding reference, like what is better naming and so on and so forth. So it's a very good one, by the way, if you wanna see how things work with exactly this. There is a section about exactly this, how const reference is working so well with so many types. Okay, let's talk about 239 actually. 239. So again, it's about 17. Easy peasy. Difficulty. By the way, it's all subjective. So we have throwing out of range, and we have stood exception and stood out of range. So is it going to be 1 or 2? Or compiler or all of that other things. What do you think?
Would it just help with 1? Because it's caching the first exception.
So order is important. So we have, so if out of range is inherited from exception. So it is a match here, if you can think about like matching that, and that's it. It stops here because if you want to have it catching the most derived one, you need to have it on the top. So yeah, let's do another one. I think I have a lot of busy stuff today, and I'm not sure I'm gonna finish everything on time. So let's do 241 with the CPP Insight and be done with that. We'll leave 276 for next time. So again, CPR 17, easy difficulty. Okay, and we have the following. So we have int of I, which is 0, and then double, which is 0. And then we call f, and this would be cout. If this compiles, the cout would be either 0 or 1. So is same v is same underscore v, which is basically is same colon, and then the value. So is same template and then colon value. It's kind of a shorthand of that. So so it's gonna have either 0 or 1 when we cout it. So I already kind of hinting that this is going to compile, but the question is like, what would be the, and let's take one at a time. So we call f with I and d. So I would be an integer, and like t would be an integer type, and then we have double. So is t and u the same? Obviously they're not, right? So we're gonna have 0 here. Then we actually call f of int, and this might be confusing because there are some rules that says, okay, we actually binding t to int, so t would be int, and then d would be deduced. So sorry, u would be deduced by d. And then if this is an int and this is a double, again, we have an int and a double, they are not the same. So that would be also 0. And then the last one is that we say double. Again, it's going to be binding to the t, which is the first one. So I would be, t would be deduced as double, and this is what we pass 0 as double. And then we have double here, and u would be deduced as double again because we have d here. So we have double, and is same v would be 1. Now, if you have doubts about anything like this, I always suggest that you reach out to C++ Insight. So this would be one of the things that I recommend you to use. So it's the same code. I'm just clicking play here. And let's take a look what's happening. So each of these would create instantiation. So we have the main template here, and then we have instantiations here. You can ignore the if-def here. Just look at the instantiation. So we have two instantiation here. One is int double, and one is double. So the int double would be both of these. So both of these would be going here, and the last one would be go into the double. And there's even a hint here that this I would be treated as double because this is what we pass. We pass t. Binding is to double. And I just memorize how the template rules work. I'm sure I'm not, I can't memorize everything, but I memorize the main thing. So I memorize that. So this is how, when I solved it, I kind of, I knew how the rules would work. So I could actually solve that. But if you don't, if you can remember, I would definitely reach out to something like this and try it out and see if things look sane for you. And I think this is a great tool to see what's happening. Okay, so we leave the 276 for next time, simply because I have so many things that I want to show you today. Okay. Okay. So there was a question on subreddit RC programming that I found very interesting to kind of discuss, because it's just an opportunity for me to take something and just massage it and show more stuff. There are links. So when I upload this slide deck, there are links that you can go and play with. So I'll start with the C code directly from the question posted on Reddit, and then we'll fix it. Just in the C land, and then start modernizing it. I think I have like 3 options. You can see the kind of a hint what I did. Okay, so spot the issue. So here's the issue, that this is the exact code that was posted on Reddit, and I have a very kind of a simple solution for that. But we'll improve it. But the very quick and dirty solution would be the next slide. But take a look what happens here. So we have a pthread array. Okay, there is a define here, and there is an array of integers. There is an array of threads. Basically, what this person wanted to do is to play with threads, where each thread that is being spawned is given a specific location in the array, and it's basically need to fill the array with, like, array of index I would be filled with I. So we have 0 to 99. So array 0 would be 0, array 1 would be 1, and so on and so forth, all the way to 99. We have 100 elements in the array. And then he or she, I don't know if this person has this check array that makes sure that just looping over the array, make sure that each of this array, so everything is 0. So make sure that 0 has 0, 1 has 1, 99 has 99. And it doesn't work. So let's take a look what is being done. So there is a loop that spawn num threads, 100 threads, and provide each thread, it provides the index here. So the index is being the index, and which is also the value that we want to place. And there is a casting happening, and to get from the void pointer to an integer, as you can see here, and it's being just assigned. And then there is a join here, okay, because the threads are not detached. So what could go wrong here?
You have multiple thread contexts accessing a global variable, right?
Yeah, but let's assume that if each of them, it's a global array, but each of them would touch a different part of the array. Technically speaking, it should be fine, because then they're not mutating the same memory. The race condition is not coming from there. What else could be an issue here?
So we are indexing twice. In pthread create, we are passing thread array plus I, and in the fill array, we are all again indexing with I.
So I have a question. What do we pass to fill array?
Oh, we pass an address to I.
We're passing an address, and the address has value, right? And what could happen when we're passing this address? Think about this for loop is like spinning on, and we're creating pthread create, and we're passing an address of I, and I is just an integer. Yeah.
I guess maybe scoping issue.
So
Lifetime.
if you think about I is just an integer. It's here. When I create a thread and I pass this address, and I'm thinking that this address would have a content of 0, and I'm now I'm creating another thread, passing this I, now the content has 1. Creating the second thread, passing the address, and thinking this thread would look at the address and say, okay, this is 1, and so on and so forth. But this is guaranteed to be like very deterministic, not going to succeed, because the address that we pass, when the threads are going to look at it, even though it was 0 when I created the thread, the value that resides in this address is going to change for sure by the time the thread is going to start looking at the value. Because I'm spawning a thread, I'm giving an address, it has 0. I'm not looking at the address yet. I'm spawning and I'm spawning another thread. Now the address has the number 1 inside. And now there are 2 threads running. Let's talk about just 2 threads. 2 threads are running. The first thread didn't have a chance yet to look at the address, the content of the address. And we spawned another one. We did plus plus to the I, and we spawned another one. Now both of them might look, and let's say there are just 2 threads. Both of them would look at I, which is 1, no one is going to do array of 0 equals 0. Both of them would do array of 1 equal 1. By the way, this is by definition a race condition right there. But now extrapolated to 100 threads, obviously many of them are, when they look at the address there, and they needed to look at address number that has the content of 4 is not going to be there anymore by the time the thread is running and looking at the address, all of them looking at the same address. So this is not going to work. Is this kind of make sense for everyone?
Mm-hmm.
Yeah, it makes sense.
Okay, so very quick and dirty. Each of them has its own, like this is all still C plus C++, kind of the C++ is here. Just a very quick and dirty. Just to prove that this is like a better approach. Obviously, this whole thing is kind of a cooked up. But if you give each of them a different address with that has a value from 0 all the way to 99, so we have a vector of 100 elements, and we just fill it from 0 all the way to 99, and each of the threads getting their own address that has the number that is designated for this specific thread. Then it's not going to happen where they're looking at address and the value already changed because we keep spinning on the for loop and I is doing plus plus. No, because the value, each index has a distinct address and distinct value, and that's what we pass to the array function. Okay, so this is pretty much the end of, like, I think I replied to this person and everything is fixed. I don't think I gave, maybe I did give him something like, okay, if you just have an array, this can show you what's wrong. But I found it as a very nice thing to kind of have a recap on threads. So we'll do it in steps. So first of all, I have a const expert instead of pound define. I do prefer const expert. I don't like pound define unless there is a specific reason to, like macros would never go away probably, but macros, the search and replace, this mechanism doesn't conform to any language kind of rules. So it's pretty dumb search and replace. So we don't. It's pretty risky. So const expert conforming to the rules of the language. So we want to keep that in using const expert instead. Then we have this fill array, which is a function that does the same thing that we had before. We have this array, and I just have a stud array of threads. We have an array of this integer, and then we spawn a thread, giving the thread this function. Thread needs a callable function, and then we can pass argument that are being passed to the callable function. That's not the best approach. We'll see better approach soon. Then I need to join all of them, and then just a very simple check, just like the check that was done from the original post. I have two flavors. One using equal, so I have this verify array and doing equal. It's the same as doing equal on two arrays, the array of what is being done here, the working one, versus having stud equal. They generate the exact same assembly instruction, by the way. So I'll show that in a second. So I needed to pass a reference because all this, the stud thread, if you look at the definition or even the declaration of stud thread constructor, there's a callable and everything else is by value. So I need to say, okay, I need to wrap it with a reference in order to pass a reference to the working array. There is no global here except the const expert. And basically that's it. So this is the start. We can actually eliminate with a very short function like this. It's a very good candidate to have, why do we need a function? We can have everything local, have a stud thread that takes a lambda. Again, it's a callable object and an index. We capture the walking array as part of the lambda. Again, if lambda is something that is new, it's first time you're looking at lambda. Lambda is a callable object. There is a body here. There are parameters to the lambda. And stud thread, what it does, it's invoking this callable object and passing index as a parameter. So this is the parameter sending index as an argument to the lambda. So this is the parameter. We send an argument to that, and then we capture this walking. You can think about it like this whole lambda is an object, and walking is a kind of a data member. So this is already shorter. I promised to show you. So this verify equal walking is basically the same as stud equal. So they do generate the same assembly line. This looks just much more natural, and this just using stud equal, but under the hood, it's generating the exact same assembly instructions. Now, yeah.
Sorry to interrupt. I just want a quick comment here. I think a big source of potential bugs, is whenever you're working with threads and you're passing things by reference. So I guess I just want to say that, for folks out there who are working with threads on a regular basis, and you're passing things by reference, that's I've struggled a lot trying to debug stuff like that in my daily.
Yeah, 100% agree. I 100% agree. So this is really I'll say that again. It's a very kind of an artificial, but I totally agree that sharing this state between, because it's a reference, and sharing this mutable state between multiple threads is not a good idea. So don't take this, of course, it's coming from this question from Reddit. Don't take it as the great example, the best example of writing concurrent or parallel program. I 100% agree. I just kept it in the same way of what is needed, but it's definitely not super encouraged to share mutable state between threads. And definitely we all struggle at one point if we didn't pay attention. So yeah, I agree. So the last thing I wanted to show is kind of a C++20 feature. If I do know that I want to have a joinable threads, I can remove this small snippet of code where I don't need to kind of wait for all of these. There is a small wrinkle. So basically, this would be okay. So in general, one could think that I could take stud jthread and just put it in, replace it with thread, remove this for loop, and we're all good, right? But the problem is that this thread join is important. We need all the threads to be to complete their stupid callable object, which is very, very simple, but we need it to complete before we verifying that the final result of the walking array and the verified array can be actually used in order to compare. So it's not enough to just remove this for loop and just have jthread. We need to make sure that everything is done before we hit this line of these 3 lines where we actually checking, verifying versus walking. So the quick and dirty way to do it is put it in a scope. So what happened is our AII would hit in this curly braces everything here needs to die. So this array needs to die, needs to be destructed. JThread destructor would do join, and we're good. Without this scope, if I just replace JThread thread with JThread here, here, and remove this for loop, it's not enough. What would happen, and you can give it a try, you're gonna get an intermittent failure. Sometimes by the time we actually hitting this verify equal working, all the threads are done. Sometimes they are not, and we need to make sure that all threads are joining. Everything is distracted, so everyone finished doing the work, so we can actually verify the threads.
So the J
Verify
means
without
so the J means joinable and
joinable
structure.
threads. We don't need to do that. We don't need to do the dot join, which by the way, this is 20. I really like. Most of my threads, not all of them, most of my threads would be joinable threads. So I can do dot join and synchronize on the join part. So JThread, can't remember who wrote the paper. Might be Peter. I can't remember. But JThread is a nice, in my opinion, a nice addition to the 20 standard. And I'm compiling with 20. I think this is the default on CLine today, though CLine already has 23. It's part of the CMake, and depends obviously on the compiler. I use WSL, which I think is 10, TCC 10, which support a lot of 20 features. I'm not using modules, and I'm not using coroutines. I'm using very subset of 20 in my kind of toy projects like these. And that's it. That would be, and in my opinion, just taking the like module what the comment that we had, that don't avoid as much as possible sharing mutable state. That's very true. But if we take the C style, which is either, let's say, this one versus this one, which is the C++, I think the C++ has a very nice syntax, kind of terse and much, I think, better. Maybe it's subjective, maybe just me, but it looks nice compared to this to the C1. But again, just me. So okay, book of the month. So what I wanted to say is Connor here. Let me see.
Kobe?
Yeah.
I had a question. I think somebody else has got their hand up too in the.
Oh,
group.
okay. So I don't have a visibility. I need to swap. I have only one screen. So if you have questions, just feel free to stop me.
Okay.
So yeah.
Christopher, do you want to go ahead since your hand was up?
And I'll go back to the.
I'll go ahead and answer or ask my question. And this is a little off topic. So you're using namespace without an actual name. I'm sure I have a feeling I know what that does, but if you could explain that, I've not seen that before.
Yeah, it's anonymous namespace. It's basically you can think about it like having static, but it's kind of more of the modern way of having this is only in this translation unit. It does have a very specific mangling that is like you cannot link from a different, because it like the mangling is something that is very unique to this specific variable. So it's just a habit to have everything that used to be static, including class, struct, variables, everything that I want to keep in this compilation unit would be in anonymous namespace. It's kind of encouraged instead of having static.
Okay. Okay, great. Thank you.
Any other question? I know I still see, Christopher, you have your hand raised. Just stop me. I can go back to any part of the slide if you need me to. Okay, book of the month. So I'm kind of doing something that I never done before. Usually I'm recommending book of the month, at least something that I went through at least slightly, and this one I must say I haven't looked at it, but I know that Connor Hogestra has a YouTube channel and a meetup group that they go over books. So right now they're doing 7 languages in 7 weeks, which I try to tune. And they had the second one yesterday talking about Ruby. I totally, by the way, recommend tuning to his meetup. It's very interesting discussions. He's very into functional programming, which I really relate to and I really like. So he did, my understanding, they had a session about category theory book, this book that I'm presenting, and he speak highly about this book, and I decided to look at it. So there is a PDF. This is from Bartosz Milewski. I don't know if I pronounce his name correctly. And yeah, so they went through this meetup, went through this book, and they also went through structure and interpretation of computer programs, the MIT book, which by the way, in 97, when I had my first year in computer science in Tel Aviv, I used to, this was our book. It's Lisp. I much more appreciate the book today than 20, how many years, 20 something years before. Someone do the math. It's a Lisp book, and it's a very interesting book. So they also had that as part of their meetup. So the PDF is free, but the book can be purchased in this website. And it does have some C++ code in. So Bartosz kind of came from C++, and then he's doing a lot of Haskell and similar. He's really into category theory. So this is a website. I do want to point out on an excellent podcast that he was a guest in co-recursive. If you have a chance to listen to this podcast, it's kind of amazing. Like what he brings in during this interview is really nice. Like how category theory helped him to come up with a better solutions, and I felt it was a very, very good episode in co-recursive. So I recommend. Again, I have the book. I just felt that I wanna have it at least start looking at it, because it sounds like something that I would like to at some point delve into. And yeah, I can't really close without the the YouTube. There's this YouTube video that people put different caption, closed caption on this book. So there is one on functional programming. It's a very geeky but hilarious, in my opinion. So and they mention Bartosz. So I definitely suggest people. It's a 4-minute. If you're doing functional programming and object oriented, lots of jokes, obviously geeky jokes, but I found it very nice and funny. Okay. Yeah, that's usually and again, sorry, I do have more idea about the books because I read the book or had at least few chapters, so I can recommend. This is something that I recommend, kind of like secondhand recommendation from listening from Connor and the meetup that he's running. But if you are interested in category theory, sounds like something that helps people to structure a better design, a better software design. So something that might worth to look at in other groups, book clubs, and similar. Okay. Stack Overflow question. So we almost 6. So we kind of speed it up. So there was a question related to, okay, I have this matrix inheriting from eigen. So eigen, it's a linear algebra, very, very famous linear algebra library. But ignore the fact that it's eigen. And what happened? This person has this matrix class, and this person wants to compare matrices, instances. And the question is, how do I do that? How do I basically have this less specialization? How do I do that? And there's a lot of so this person just copy paste the solution that he or she had in this. It's a he. You can see here. Had in just pasted, but there is a lot of things that just wouldn't compile. This semicolon here would not. This whole thing would not compile. You cannot really specialize less like this. First of all, std_less is defined in this stud namespace. So there's a lot of things, and I felt it's kind of a good idea to at least discuss what are the options. If I have I have a type and I have instances that I want to compare, what is the best approach of doing so? Okay, so let's start the journey. And I think he had it at the context of StudentMap, but I can't. Yeah, StudentMap. And the person says, I also want to specialize stud hash in a similar able to use it in StudentMap. This is kind of I don't know if kind of an oversight from his part. There is no stud hash needed in StudentMap. It is needed in the unordered flavor of map, the unordered map, but not for StudentMap. So just ignore the fact that there was a question about stud hash. Okay, what is StudentMap? Like how StudentMap look like, and what is the default compare? So StudentMap has a key and value, and there are 2 other template parameters that are defaulted. So you don't have, if you are okay with the default, you don't really need to do anything. You just need to have a StudentMap of something to something else. And I believe a lot of us, if not all of us, we know about StudentMap. It's this one is not a hash map. It's a very common kind of a confusion that StudentMap, because I think from different languages and different paradigms, it's StudentMap is always like a hash map, but in at least in the standard template library, StudentMap is a binary search tree. So there are nodes. It's not a cache-friendly container, but it's an okay container for some cases. Like in some cases, it's okay to use it. So we have a key, we have value, and then the default compare. I'm kind of ignoring the allocator. The default compare is std_less of a key. So what is std_less of a t? So this is how it looks like. So std_less, like in the guts of the implementation of StudentMap, when it needs to compare 2 elements, it reaches out to the compare function. The default here is std_less, and it calls it. This std_less looks like a function. It's a callable object because of the overloaded operator paren. If it's new to you, if it's the first time you're seeing this, just ignore this whole glibc cxx14. Just ignore this, and ignore the binary function inheritance. Just ignore it. It's just type diffs. If it's the first time you're seeing this overload, it makes the name functor is basically what we see here. Structless, when we get an instance of structless, we can call it like a function because this overload function that it's kind of a function overload or the parent or whatever. When I have two instances, I can call less. I have an instance in my head. It's a stateless struct. So I have an instance I can call something less than something. What happened when I call this less function, it looks like a function. Inside it calls an x. It invokes an expression x less than y. So x and y are template parameter. That there are actually instances of TP. TP is the template parameter. So the only thing that needs to happen is that x and y instances, so the types, they need to have a less than operator. So if you have an integer, it's built in the language. If you have double, it's built in the language. If you have anything else that is built in the language, like short and so on and so forth, you're good. If you have something that is not built in the language, user-defined type, then the compiler would say, hey, I don't know how to take a struct of matrix in this case, less than another struct of matrix or class of matrix. I don't know how to do a less than. You need to teach me. Like the compiler would stop, say, studless is trying to do matrix X less than matrix Y. I don't know how to do it. Teach me how to do that. And so there are multiple ways to do that. And this expression would yield true and false. And this is how the whole thing would be actually resolved and everyone is happy, world peace, and so on and so forth. Okay. So what is the best straightforward approach here? So there is an answer from Stackoverflow, and I have the link there, so you can then look at it later. But I just highlighted two things. So and it says this person says the following. The question is whether you actually want to specialize studless. Studless basically call a comparison operator defined for your types. That's exactly what I said, right? So you can provide that operation instead of specializing the template. In other words, this person says, don't go too far and start specializing. Just define a less than operator for your types, and you're done. Now, if you don't want to provide a comparison operator because of whatever, but still want to use the type in associative container or with algorithm that needs a comparator, for example, StudSort needs that, you can provide an external comparison functor by other name if you don't want to confuse others. So let's say you're working in some environment that operator overloading is banned. I don't know why, but let's say it's making up a. So you can still provide a compare function or a compare functor, which is a struct with operator parent, to the StudMap, and it's going to work. So long story short, we need to teach the compiler how to do, how to compare two types. Okay, one option. I have this matrix. I can define a less than operator as part of a member function. Valid, kosher, it's going to work. You can stop here and go home. That's fine. So I'm not actually looking here at the implementation, but the implementation needs to yield true or false. That's pretty straightforward. So that's one option. Very straightforward. A second option, you can always define a non-member compare functions. Remember, I told you, if you don't want to have an operator less than, you can have a non-member function that takes two types that you want to compare. And again, it needs to yield, this expression needs to yield true or false, returning a Boolean. And here's my map. I have a key. I just went with the same type that this person was asking in Stack Overflow. I have this type, matrix. It could be stud string, right? Any type. And then the value integer. We don't care about the value because we compare against the keys, right? The whole tree is sorted by the keys. And then I have a compare function. I need to pass a compare function. So here's one way to do it. And then if you look at the constructors, I need to provide an instance of this function, which is what I'm doing here. I'm passing a pointer of this function. Everything would work well. This is also valid, definitely kosher. You can also do that, stop here and go home. That's fine. Okay, it's another variant of the second option, actually a variant of the first option to be exact. I have a matrix of whatever. This is one type. I have this is the key. We have the value int. Now instead of the compare free non-member function, I have a struct, a stateless struct that has this operator paren. Actually, yeah, it's the same. It's kind of the version, like another version of this. It does the same exact same thing. It looks a bit less cryptic. There is no decal type of comp and so on and so forth. And the compiler is well suitable, well fit to create a compare instance. It's a stateless struct. And then we have an instance that knows how to take two matrix and compare, because I have the implementation here, returns true or false. Okay, here's another variant that is a non-member, it's a friend, and it's implemented inside. There's another variant that I don't show here. It's exactly the same, but it's implemented outside of the class. So I'm just saying this is a friend, and I'm defining it outside of the class. It's almost the same. There's an ADL things like argument dependent lookup that is related here. Let's ignore it for a sec, but it's just I want to show another option that is, again, very kosher, doable. It provides the exact same results as all the others. What do you want to choose? It's really up to you. I usually, if it's simple, I usually just do this. If I don't need anything else, it's like the most straightforward. It's a member function, less things to type, and I'm done. Because stdless would compare to matrix, it needs an operator less than, it would find this function, and I'm done. Okay. Do we want to specialize stdless under stud namespace? Well, you could do that. It's not really encouraged. There is no really, I don't see any incentive of doing it. I don't think, unless people on the call can tell me, oh, it's much better if you do it. Maybe there are some cases where it's much better. If you want to do that, this is how you would do it. So you have it, and there are very few things. I don't know, maybe this is the only thing I can remember. There are very few things that you can specialize or implement under the namespace std. Everything that is outside of what is permitted considered to be an undefined behavior. So you need to be very careful. Okay, so I can come and say I specialize stdless. It used to be just template T. So I'm specializing with a matrix that takes T rows and calls. And I'm just doing a compare. Conservative lexicographical compare. It's one option. But it does, the implementation doesn't matter. The important part that you could have a std. By the way, it's the same as if I remove this namespace stud and have struct and then have stud : just before the less. It's the same thing. Okay. Here's the final answer that I really like. The problem is that I want to specialize stdless using a template. I said don't. Stdless meant that the design was to call the less than operator for a specific class type. Specializing a class with no less than operator is needlessly confusing others when they read the code, because there should be, when I read the code and see the specialization, like there should be a reason why this person went all the way to specializing something under the namespace stud versus having a simpler approach of adding a simple compare less than operator as part of the class, maybe a friend. So specializing is basically pointless. Just implement it as correct overload, and you can use it in StudentMap. By the way, not only in StudentMap, also things like StudSort and similar that they need a compare operator. This would also work for these use cases, like all kinds of algorithms that needs that. And you can always look at my GitHub for these examples. Now, there was something that I was posting while I was creating this slide deck. If you try to create, I don't know if it's readable, but if you try to create this StudentMap, go back here. If you try to create this StudentMap with decal type of comp pointer, so it's a pointer. So I'm actually telling StudentMap, here's the key, here's the value, and your compare function, it's a function pointer. I don't specify the instance of the function pointer. So it's gonna be null. And it's gonna crash. So you need to specify a compare function. I just play with it and kind of amusing. And there was a very nice fix by this person named Daryl. And I'm not going to show it, but you can take a look at the Godbolt. It's a very nice approach that makes sure that if you don't pass anything and it's null pointer, it's gonna fail to compile, which is it's using concept, and I really like the approach. Please take a look at that if you are interested in that. I'm kind of short on time, so I'll continue. Okay, so last time we had this WalletFox slide, and here's if you were part of the previous session or you watched the recording, this is probably familiar. You're probably familiar with that. If not, I'm gonna give a very quick overview. We have two structs. One is rectangle, one is semicircle. They have constructors, there is data members. We have this overloaded pattern, and I'll explain it in a second. But what we do is we're using StudVariant to take these two unrelated types and put them in a vector. StudVariant is a very nice approach using type erasures and so on and so forth, but it's a very nice approach to take unrelated types and put it in a container, actually making a heterogeneous container where before StudVariant, we need to do all kinds of tricks of having pointers and having a base class, kind of a dummy base class and all kinds of crazy stuff. StudVariant is a very nice approach to avoid all of that. Now, we want to compute the area. Each of these types, they have a different way to compute an area. For example, the rectangle one has A times B. Semicircle has different, there is R square, pi, divide by 2. So there are two different ways to compute. So without going into a lot of details, we did it last time. There is this StudVisit. StudVisit takes a callable object that might contain multiple overloads. Okay, and then it takes something that, in this case, it's a variant that we can use to pass it to the callable object. So basically, sorry, if I have an instance of rectangle and I'm calling area with an instance of rectangle, so the variant actually holds a rectangle, there's going to be some of it is a compile time trick, some of it is there is a runtime dispatch that the rectangle would be invoked. And same deal for the semicircle. So what happened here is that we have a vector of these shapes. It's a heterogeneous container, and we do accumulate. What we do is we compute the area and we sum all the areas, just the total of all the areas of this either rectangles or semicircle. So Ben had two comments. One is mpi, which is a type def. Sorry, it's a either const expert or define, can be replaced with something else that I'll show in a second. Plus this accumulate is better expressed as transform reduce. And I wanted to, since I really like this approach, and I want to make sure that people actually understand that I created a slide just by showing that. So everything is the same here. So the rectangles, semi-rectangles, this type def, all of this is the same, except the transform reduce is replacing accumulate. Okay, so what is transform reduce is doing? Transform reduce does two things. It runs an operation on an element and then fold the whole thing into a single. So what happened? We have an initial value. We take an element, we do something with it, whatever the function of the transform is doing, which in this case it's doing area computing. So we compute that area and then we do the reduce. We call the reduce function. In this case, it's doing sum of everything. So we have the transform takes an element. So we actually just going over, and transform reduce, by the way, there are multiple overloads. So this is just one overload. It just take one range, but there are multiple overloads that takes actually two range, and they do zip of this of the two ranges. This is just one overload that take one range. We iterate over each and every element. We run area, we get the value, and then we sum it to the, we take the sum of the previous value, add the current area, and eventually we'll get the total. So I really wanted to show that. Thanks for Ben for mentioning that. Another thing that I wanted to show is the pi, which we get from 20. So we don't need to have our own pi. So stud numbers has pi, and we basically doing as instantiation of this template with double, and we don't need to have our own pi, either const expert or pound define or anything like this. We can use the one that comes from stud numbers. Okay, by the way, if you have any question, you need to stop me. The last thing before we go into the Leetcode is this this WorldFox slide, how not to use shared pointer. And I just want to encourage people to rethink before you reach out to shared pointer. There are very few examples that I have in mind where shared pointer fits very well. Don't use shared pointer to have a garbage collection. I've seen a lot of cases where shared pointer was used across the entire application. And you can see a lot of these examples on the web. And it gets very complex to understand who's owning what. There's a lot of cyclic dependencies, so you might run all kinds of tools that detect memory leaks. So and they would detect memory leaks because you're not releasing the memory, because there is a cyclic dependency, so nothing is basically being destroyed. And then you fall back to weak pointer, and a weak pointer is a dangerous, not a dangerous, but it's kind of a tricky tool, because weak pointer, you need to make sure that you have an instance. So there is this dot log that you need to make sure that you're using. So there's a lot of things that really complicate the design. And what this slide is saying, yeah, you could technically have everything as a shared pointer, but instead have a vector of nodes, and a triangle just have a non-owning pointer. Remember that shared pointer has a make shared that actually takes the control block as as one piece with the object. There's a pros and cons for doing so. But just bear in mind that that's one thing that makesure is doing versus doing a new and not using makesure where the block and the object would be in two separate new calls. There's a pros and cons for each of these. Cache locality is a good thing if you have all of them are in one chunk, but sometimes destroying stuff would keep, if the object is really big, it would keep it alive. Well, the memory is alive. The destructor is being invoked on the object, but the memory is alive and might take. There's an overhead if the whole thing is still alive because there are reference like weak pointer referencing to it. So the control block needs to live, and the control block is glued to the object T memory block, although that object T was destroyed. So there are all kinds of things. My suggestion to you is stick to unique pointer. Shell pointer, one thing that I can think of, there are multiple, but one thing is I have a message that I'm passing to multiple consumers, and I don't know who is gonna consume it less. So I'll have a shell pointer. There's gonna be consumptions, and the last entity that consume it, it's automatically being deleted. That's one example of possible usage of shared pointer. But again, just think well before you use it. Questions? Okay. So the next thing is a Leetcode Roman to integer, like Roman characters to integer, and it's a Leetcode that I just happened to kind of find. It was a few months ago, and here's the story behind it. It's by the way, it's something that I never done during this. I think I never done that during the meetup where I actually showing some live coding. Hopefully it's gonna work. If it's not working, it's not gonna work. I'm not gonna do it again, or maybe not exactly the same thing, but I'll try to get it work. So what happened is that I was reading, I read few chapters of Clean Craftsmanship, which by the way, it's not a very thick book. I really recommend people to read. I personally really like books from Robert Martin. I usually read them very fast because the way he writes is the same way that he talks and speak, and he has a very specific way where he actually transfer his knowledge, and I really like the way he teaching others. So there is at least a few chapters on all kinds of aspects of TDD, and I am doing some level of TDD, but this book actually gave me another perspective on TDD that I wanted to share, and I wanted to demo here with you today. The idea behind the TDD is you have a failure, you fix only one thing that brings you to green, and then again you do you add something to the test that would fail, that's green, that's red, you add the code to make it green. Just one thing, you need one thing at a time, very, very small cycles. There is another element that is while you do the whole thing, you might need to refactor. So, okay, I'm doing something and I think I need to stop here, do some refactoring. I'm not changing I'm not adding implementation, but I'm changing the implementation to be able to accept more code while doing the TDD. Now, there's a lot of things as part of the book. One of the things that I really like, actually, first time I'm actually looking at, and there's, by the way, the book has references to a YouTube recording that actually show it's the book has like a very thorough, almost step by step of what he is doing. And one thing that I was kind of odd that I never done, and I'll try to do it now, but it looks very stupid. But when I solved this Leetcode question, I didn't have any constraint of time, so I said, okay, I'll do it exactly as Robert Martin is instructing us to do, exactly how he shows that. And there is a lot of very like stupid things that you add another stupid if, and he's saying like, at that point you're probably saying you're just adding ifs just to get the thing working, and he said yes. But what I realized by reading is that while he was doing all of that, he actually developed a thought, a specific idea that even with adding all kinds of ifs, to some extent, of course, you don't have like millions of ifs, but some of them looks just redundant just to get something compiling. So so I'm gonna try to do something similar. I don't want to go over, let's say 30 minutes from now, hopefully less. I am going to make some shortcuts because I can't really go and do the whole thing because I'm explaining and all. I thought it's a nice demonstration of TDD, obviously subjective. So let's give it a try. So we have this Leetcode. Let me see. I have this. I don't have the actual Leetcode. Let me see. The Leetcode, actual Leetcode. Okay, so the Leetcode itself. Give me a sec. I'm going to just show you the Leetcode question itself. Okay, wait. Okay. So value is always valid. We have Roman number, numerals are presented as 7 different symbols. We have I, V, X, L, C, D, and M. And this is the values. From I is 1, V is 5, and so on and so forth. And there are examples. Most of us know how to do that, but they explain. Now, I can be placed before V and X to make 4 and 9. Then we have 40 and 90 and 400 and 900. All is valid. I think I've seen that. Okay, it is guaranteed that S is valid. There is a range, and yeah, that's it. That's basically the question. Now I'm gonna start doing that. Hopefully it's gonna work. I kind of practiced a bit, but you can never know. So bear with me. So let me share my setup. Okay. Do you see my setup?
Yes.
Okay.
Yeah.
Awesome. Okay. So a bit explanation about my setup. I have CLion, and I'm using Conan just to bring GTS. I'm not actually using format. I'm not using format. Oh, maybe I am using format. I can't remember, but I'm not really using format. I just using CMake toolchain. My CMake is really simple. It adds GTest because I'm gonna use GTest for that. And what I'm going to do, so it's very complex because I have a scenario in my head that I want to follow, but obviously I'm going to get things in a bit a different order. But just bear with me. It's the first time I'm doing that. Okay, so here's what I have. So let's remove the Conan file. And what I'm going to do, so this is my G test. And this would be the CPP. And this would be the header. Okay, so the first thing first, I have this G test and I'm going to just run it. And nothing. Okay, let me see. Okay, let's just do that. And the idea is that I have an empty environment, empty test, just to see, just test the water, just see that everything works. It's again, this is part of the book, and I don't know why it's not running. Okay, let's see. Okay. Oh, okay. Give me a sec. Give me a sec. I think I know what happened. Okay, give me a sec. Obviously, if it's not working, I'll need to do it next time, but give me a sec. I think my CMake doesn't have this part, I think. Let's take a look, 1 second. Sorry about it. Okay, let's see. Okay, let's see. So now. Okay, let's give it a try. Something again is busted with my setup, but let's give it a try. So, so I have a header that has nothing. So what I'm going to do, I'm going to just add a function that returns an unsigned. Maybe we should do it the following. When I look at the file here, what I want to do is create a std string that has nothing. This is the input. Then I'm going to have assert equal of 0, and then I'm going to have, so there is a namespace here, so I'm going to use it. And I'm going to call a function getNumber that pass an input. And there is a way to say, okay, bug with the input. It's not really important, but just bear in mind that this is actually possible. Now, obviously, if I want to doesn't. Second. Let me try to reset the whole thing. Okay. So I'm compiling and okay, I need the test one. And it says no such thing. And this is the first thing that looking at the book or by the book, literally by the book, is asking you to do. So we start with having a header file, and it returns an unsigned, an integer, get number. If I'm not getting it all the way to the end, I'll get you the solution and you can use it. And for now, what I'm going to do, I'm going to have a string input. Okay, so this would be the header, and okay, so we compile again, and this should compile, and hopefully I can run it. Okay, now it's compiling. Let's see if I can run it. Okay, so running it. Yeah, empty is fine, all good. So this is one cycle that looks good. Now the idea is to take the next one. They call it 1. Okay, and now I'm going to have an input of I, which is 1, and assert equal. And again, I'm going to have a cycle. I need to have a fader, then I'm fixing it, and fader. Now, the first thing that he would do, now it failed. He would put 1 here. Like, think about the simplest, not even worth having, but the TDD thing is actually going to, and I know it looks like a waste of time and all, but this is a very simple, like relatively simple problem to approach. But if you think about a bigger system, you want to have maybe the skeleton, so you want to have one by one happening. But let's say we have 1 and this would succeed, but then we'll have 2 would fail, and the cycle would continue. What I'm going to do here is the following. I'm going to have if S is I, I'm going to return 1. Just to make this thing happy, I need to make it, and then I can have return 0 here. Does it like it? I need to have. I don't know why it doesn't like the I. Okay. It should have a compare function. Okay, let's build it. How come it doesn't have a compare function for this? What am I missing?
Did you include string?
Oh, thank you so much. Yeah. You know what? I actually had the same thing and I completely forgot about, yeah. Thank you so much. You need to include string again. By the way, it's good to include it on the header because I'm using string there. By the way, I quickly moved from string to string view. I'll show it again. So if I try to run it, it's gonna be fine. But what I can do here is stop for a second and refactor and say, okay, just return 0. Now, this should not happen. But while we actually building stuff, this would happen. And what I'm doing right now is it just to have something very kind of strange, is to have an unsigned int of max just to get things. Okay, and then again, cycle just to see that everything looks good. And then I'll do the next one, which would be 2. And when you look at the chapters, you'll see.
Why? Just to say, why do you return unsigned it? You return no, sorry, never mind. I'm blind.
Yeah, because it's not going to be negative, and but it you can if you want to have an in, you can have
No.
an
I mean, I just was seeing in forget number, forgot that there was an unsigned before, and so the numeric limits didn't match in my head. But yeah, I'm blind.
We all blinded in this hour, believe me. So I have 15 minutes. So I really want to show you also the rest of the. So I I kept adding this 2, 3, and obviously it's not going to scale. But one thing that I did do as part of the refactoring is that I moved from string view, and obviously I can do this as well, and back to the header. And, oh yeah, I had string view here initially. Now, after adding all this intermediate, I would say test. So I had 2, and then 3, and then 4. So what happened is that at a specific time, you're saying I want to refactor that. So because I have 2, and then I have 3, then I need to do something very dumb over there. And then I have 4. Now 4 is not like 4 of these eyes. It's something like this. And now this is the first time. This is the first time that I need to stop and think really like what's happening here. I need to have this notion of I and V that are actually glued together. This is something that needs to be is look at as a single thing, which is 4. So the input is empty, and again, just imagine that there is a 2, 3 until I say, okay, how do I manage to have like I and 4? So obviously we need to start looking at each and every character, because we got 1, 2, 3, and then we'll have big array of characters, a big literal that we need to start looking at. So I'm gonna have an unsigned int result, be a result, and then I'm going to have a for loop because I need the index. Now, definitely can have for loop with a signed number, signed type. That's fine. I just got used to do that. Okay. Now we need to take a look at each character at a time. This is the refactor part that I mentioned, that you need to stop and do something again, S, because I used to think about strings as S, but it's input. And then we have this switch. This is the first time I say, okay, I need to look at a condition of, okay, this is C, and default should not happen, but let's say just returns 0, should not happen. because we said that everything is valid. And then we have a case of when we have I, it's pretty simple. We have plus plus of result. Okay. And then we just return result. Okay. Now everything should pass except the for one. We're still not handling for one. The for use case. But 1, 2, and 3 would do plus plus on the result. So yeah, so 4 is failing with input 4. This is why it has this nice with input. Okay, so now we need to do, and again, there are multiple ways probably to do it. This is how I solved it. I want to look ahead. So in case of I, it's not only just doing plus plus on the result, but there is something else that I need to do. I need to look at the next item. I do S because, okay, and now one option, okay, so default, if we have a null terminated or something like that, we just do break. Okay. Actually, what? Yeah, just do break in terms of there is nothing there, and if we have I, sorry, if we have that, we do nothing. If we have actually, if we have default, we definitely want to do plus plus on the result. Because this is I, and then case of V, we'll do result plus equal, and we consume that, so we need to move the index and break. This refactoring should have, and then this result goes away. This refactoring should help us with the I and V. Yeah. So I'm going to kind of, since we don't have a lot of time, I'm going to now just imagine that we also have 5 and 10. So 5 and 10 would be in this level of switch case. I'm going to have a case of 5, and sorry, I'm not actually writing the test case because I want that to be so we kind of finalizing that. This is the case. We'll make it much nicer. So case V would be result plus equal 5, and we break here, and then case of X would be result plus equal 10. So just imagine that we have, so I went through all that. I'm not showing it here. I told you I'm gonna, so we have 5. And we have also 10. And all of this should pass without an issue. Okay. So the next thing I was doing, I start playing with more and more combination, like valid combination of the Roman, and I ended up with a lot of more test cases, but and some of them, of course, start failing, and I needed to address all the requirements that we saw that X has uh, has L and C and so on and so forth. So I ended up with kind of a hybrid solution before everything. So for example, maybe what I'm gonna do is I'm gonna copy paste for my notes so you can see the intermediate solution. So what I'm gonna do, so I just don't have time to type the whole thing. The way to result. So let's see. Yeah, I'm gonna just refactor this one so everything is okay. So we have the I that we saw before. V is just V. X has all this stuff, and C all of that. So you can see that there is four. We have 1, 4, and 9. We have 10, 40, and 90, and we have 100, 400, and 900. And then the 500,000, 50, and 5. They are separate. Now the last thing this is working. This is basically something that is definitely a working solution, but take a look at what's happening here. There was one cycle that has nothing to do with failure, but that I actually added in order to make this whole thing much more compact. So what do you think we can do here? So we have these blocks. What could we do?
Look for commonalities, maybe?
Yeah, exactly. It's really, take a look. It's the exact same thing beside the values here. So this is 1. There is a 40 here, and there is a 90. So it's 1, 4, 9, 10, 40, 90. So,
Yeah.
but they are the exact same blocks. So let's write a template. I'm gonna just copy paste because it's already late. Let's have a helper function that just mimic the exact same structure. And again, you have multiple ways to do it. So there are this get special takes a character, and it takes the first value, the second value, and the third value. So these 3. Okay, and I need to have the case. So the case here is different, right? There is a V and X here. There is an L and C here, and there is a D and M here. So the case, the default is easy, but the case is different. So what I did it as a template parameter, a non-type template parameter, which is really perfectly valid. Now, this whole thing with repetition becomes something like the following. Copy paste it from my GitHub. So the whole thing becomes the following. So we have I, V, X, all the types. 3 of them, they have a spatial handling where there might be something. So I might have V and X. X might have L and C, and so on and so forth. And just looking at the results, at the rules, and the repetition came up with that. This is actually a very fast solution. It's kind of on the top of the Leetcode speed, and it is correct. And again, I kind of didn't. I meant to show you like the exact TDD. Obviously, it didn't work well. Time is an issue here. I need much more time for that. But you can imagine the cycles that I went through in order to add one more thing. And one of the things that I remember from the book, that he had this exercise that he was showing, that he said, I have this design in my head before he actually started doing any coding. And he had design in his head and was like drawing the design, but going through the TDD approach with this small incremental changes, the whole thing was completely different from the design. It was much simpler than the design, much more kind of robust, terse, and he was saying, you see what happened? I could go and implement before actually doing any test, implement the whole design that I had in my head. And there was like diagrams of inheritance and composition and all of that. And at the end, it was a very simple, I don't know, couple functions, and the whole thing was pretty done well. And it's all because he's saying that the way if you do this iterative, small, almost stupid process of iterative testing, it helps you to kind of get to the right, short, correct approach much faster, even though it looks like even slower, but you end up with a better design. And I really tried that. I took it as an exercise for myself. Say, okay, I don't have issue with time. I'm gonna do it. Very stupid, and I really like the small incremental changes. Obviously, this is a simple. It's a simple question, but it should work with a bigger and more complex ones that I definitely want to try out at some point again.
Kobe, I was just going to make a comment. I think this sort of development practice forces us to look at it from the perspective of the caller of the code,
yes,
instead of looking at it from the perspective of the implementer.
Yeah,
which is what we tend to do by default. Yeah, from the client, exactly.
From the client, yeah.
And that ultimately produces more usable code or more readable code, if nothing else.
Yeah, readable. Hey, Kobe, I've not used string view before. Are you concerned with the IDX +1, that index when you're peeking ahead?
No, I picked string view just there was no performance thing here. I could definitely pass a const reference of a string and be okay with that. It's if this looks a bit kind of confusing, just ignore the fact that it's string view. Just it's a pointer and a length, and I'm not mutating anything. Everything is const. Even the string view, I had it as a const in the definition, so I could leave it as a const to string ref, and everything would be fine. Nothing. I bet the code that is generated is identical. So I'm sorry if it's if I added too much confusion.
I guess I'm still I would be still concerned with the IDX +1. You know, when you're peeking ahead, I wonder if that could at some point be problematic.
You have a buffer overflow potentially, out of bound access.
Exactly.
Yeah. Since I know that it's it's a good question. Since I know it's a null terminated, so when I'm looking at something that is valid, the next one could be null terminated, and then I'm done. So if it's an I do ++, and I'm done, and the whole thing, and the loop would be saying, okay, I'm doing ++, so I'm hitting the null terminated. The for
null
loop,
termination.
the for loop is checking that. Maybe I should. When I do ++, the for loop would be evaluating this. This is null, done. So I'm never actually picking beyond, this is the issue, beyond the null terminated.
Okay.
This is a because deref beyond that, yes, undefined behavior.
Good answer. Thank you.
Okay, folks, let's have dinner. Thank you for showing up.
Thank you, Kobe. This was
Thanks,
great.
Kobe.
Day.
Awesome,
Good
man.
night. Thanks. See you next time. Bye.
Thanks, Kobe.
Thank you.